Okay, so it's been for almost a week now. I'm working on the project uh, using um, microcontroller. This one STM8L151 F3U6 and communicating with MLX90614. And at first, I think it's gonna be easy. Just try to make the I2C system stuff work, but it's turned worse. And I try to figure it out and finally be able to enable the peripheral clock for I2C stuff, which is in this initialize things. No, it's here, somewhere here. Yeah, to enable the clock and then do some of the initial setup for I2C peripheral to get it working by setting the base frequency for 16 MHz CPU, which is I already use 16 MHz, and they have to do some configuration like I'm not sure what it's called, but it's maybe the time that it was the minimum. No, it was the maximum time. Not sure it's rising or lowering, rising or falling time. Not really remember. And we have set the speed, and the speed is 20 kilohertz or 20,000 hertz. So it's very not that fast. It's not going to 100 kilohertz because I right now troubleshooting and I need low frequency because my scope I don't have scope. I have Arduino sump logic analyzer. It's UMP sump logic analyzer with this OLS open source logic analyzer, I believe. I'm not sure. And this is just boring initialize part, but I try for a few days. I do the different things in different days, and in one day I decided to Google up and found that someone actually made the code for it. And I'm not sure that I closed the tab, but someone actually made the code for it for STM8S and MLX90614. And I tried to adapt from that code to STM8L, but it failed. So I decided to copy some portion of the code for the CRCH checking, a read word and write word from a SparkFun Arduino library and do some modification to it, add some debugging message, which is a way return error because something is very wrong, and I already know what is wrong, but I don't know why. But I know how, I know when, but I don't know why. So here we go. So actually I follow some of the guideline in datasheet of Melisys, who manufacture the MLX90614, and I find out that yeah, they have something that I mentioned before, the time for the rising costume, something like that. So they have a diagram. Let's just this down exposure so you can see it clearly. So it's begin, and then it's sending it's sent start bit, doing like this in the code part of the code. Send start bit and send select address, which is you have a 7-bit address and you shift to left for 1 bit, and it's here in this function. And here it's gonna check for the if I take a look in, if you take a look in this paper, it's blow out. It's blow out. So you see on the you have on the leftmost is a SB bit or start bit. So basically in this part of the code is checking if the device is act. So they have two of things when we want to communicate with the sensor. So take a look at this very simple diagram. So first we send the start bit like this one, start bit, and we send a 7-bit slave address that I told you earlier to shift the bit to left for 1 bit, and then they're gonna return this part. No, before he return this part, so I just told you earlier that I shift the bit, so the last significant bit is gonna be, it's gonna blank. So you use that bit to indicate that you want to write, request for writing, or request for reading. So in first is you request for writing. So I'm gonna use this function, this portion of the code. So I'm gonna send address and request for writing, because we want to write to memory register for reading and temperature. And after that, the UI will send acknowledgement. And if you take a look here, we have another diagram somewhere. So let's scroll it up. Pretty sure it's somewhere. Yeah, this one. So if you see, we have start, self address, a read or write request. In this case, we first of all we request for writing, and then they're gonna be acting bit right here between next 8 bit of data that we're gonna send. So here we go, we have here the legend. Take a look here, we have a represent acknowledgement bit. So if it was 0, it's act, which is mean when you, it's like shouting out I2C address and someone is out there and the address is matched, they're gonna shout back, hey, I'm here, like that, and my controller gonna know, hey, you there, and gonna send the data to you. So here we go. I tried about, I think, 3 days. I can't even get it to act. And the concern about something I believe to be timing. So first of all, according to datasheet, this datasheet, they have more than in the library, the peripheral, standard peripheral library, blah 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 stuff. It have some of these register here that is config the riser time. So it's riser is T riser or riser time. So the minimum of this sensor, this one here, this is a SM bus base, so it's just like a subset of I2C, and they have a maximum of riser time. And in peripheral library is configured to 1000 nanosecond or 1 microsecond or 1 nanosecond, which is not enough. It's not enough, it's too long for sensor, I believe. And I just put there to 0 to make sure that it's gonna be as fast as possible. And when I go to the logic analyzer and measure the width of the 1 clock pulse here, this clock pulse is about 10 nanosecond, which is very fast for human, but it's very good for this sensor, because I believe the maximum is 50 nanosecond, I believe. So after doing that, and I use a lower frequency for easier, and it's a Arduino stupid logic analyzer friendly frequency, because it's very low frequency. I finally get act from the from the sensor itself. So okay, we go back to this portion of the code. That's where we want to read word, we want to return the temperature value. So just use touchscreen. Oh, touchscreen is, yeah, it's not that great on Linux. Right, this one here. Okay, so send the start bit is working, and then since slave address is working fine, and we got act from slave, so it's gonna send command, and we need to check for act from slave. I'm gonna do it later. I'm gonna try to fix that part, and I will tell you that where is the thing that caused thing not work. So assume that we send the command completely. In this case, it's 0 by 07 in hexadecimal. So we request the temperature of the object. They have a RAM, memory mapping stuff of that you want to call. This is a very cool, neat thermal sensor. And yeah, it's weird. You need to send a repeat start in first time. After I read this, I think, yeah, you got start and then you write, you stop and you start again, but in reality it's not that. So I don't require stop bit here. I just send the start again, because according to data sheet, again I have a data sheet, I print a lot of them, is what here, sequence master transmitter. So here we go, let's take a look at this. So it's too dark, can add some light on it. So if we take a look here, we have a legend here, start, and EV5. So EV5 responding the SB equal to 1. So it's gonna check after I indicate that, hey, I want to send the start bit, and this EV5 is gonna checking if the start bit already set. If it's yet, it's gonna jump out from the while loop and continue address sending. So this is gonna send address and gonna wait for the acknowledgement, which is in this case acknowledgement is great. And blah 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 blah. Assume that we send data correctly. When we go to here, we have a pause bit or stop bit here, and go back to here, EV5. So EV5 SB1 clear by reading SR1 register followed by writing register with address. What it mean? It means that they have some stated register that when you read it, you're gonna know what happened. So this is a SR1 register, and the bit that we read is this one, the SB. If it's returned to be 0, is what no start condition, which is something is went wrong. Maybe you writing into I2C CR2 bit incorrectly, but if it's set to 1, it means that start condition is generated, so it's good to go. So that's why it can hop out from this while loop here, and then it said that after we reading SR1, which is we did in this while loop, it's gonna clear after we read. Yeah, we already done, and by writing the data into I2C DR. So here we go, we have DR. So we write the data in request for writing from this sequence. Yeah, so it's gonna clear start bit. It's gonna, yeah. Then when it's clear, I can send start bit again. So why didn't it stop? Okay, back to our subject. I think I've gone too much, and it's about 13 minutes now. I noticed something very weird. When the data reading from, we read 2 times for low data byte and high data byte and PEC. You're talking about PEC, still have problem with a rest of it, because the data is not reading correctly, and the data is actually what remain in the I2C DR. So last time before I actually execute a I2C read to return the value of I2C1 DR, I perform this I2C read address, and the result turns out that when I read it first time, it was very similar with that values, and I just used GNOME calculator, type in the hexadecimal, no, it's not decimal, type in the hexadecimal, B5, yeah, B5, hexadecimal, and take a look at the binary, and I immediately noticed that this is the right request that we sent in I2C read address, which is means something is went wrong. Either the microcontroller cannot receive the data and put it into the shift register for the DR, or something went wrong with sensor, or sensor does not know that they need to send data back to microcontroller. So I will investigate more by using this Arduino as some logic analyzer that I told you earlier, and take a look at the waveform, and I'm very lucky to capture the moment that made me realize that why it's not working. Let's take a look. So let's climb torture. My phone is pretty hot right now. Okay, just climb up. So my logic analyzer noticed that we have started. So before this thing is showing up, I use tool, and then this this was tools and I2C protocol analyzer. So I will read for you. So we have the start bit, and then we have the data that I encoded to be 1 0 1 1 0 1 0 0 0, which is set up right to slave, meaning that I request slave for writing something to its memory, and then I got act, which is mean that I shout out loud the slave address, and it was out there, so they can, so no, it's not there, it's what out there. It can know immediately that, hey, you calling me, I will call you back. So it send act back to my controller, so it immediately know that, hey, this address exists on this line. And then we go furthermore, yeah, gonna take a while. You go furthermore, yeah, here. And then I got something similar again, encoded as 1 0 1 1 0 1 0 1 1. Oh, 0, sorry. It means that it required read from the memory of the MLX90614, and we got act, which is mean the timing is good, and address is exists on the line, and then it's reply back. It should be 1 2 3. Yeah, it should be. Never mind. But something is missing between these gaps. So this part we have start and request address request for write, and it's gonna be empty line. The SDA is pull hard, clock is pulled down, and SDA line still high, and then I just it's very hard to do that. And then the line is free. Oh no, I think I'm gonna use my 2 finger. Jeez, it's very hard. So here is the part that we request for writing, and this is part request for reading. If you go back to the code, so here we have start bit already before we write address, and then it's go all the way to here to start again a sending we call a restart. Yeah, and we send the read address, which is pretty weird because in these gaps I don't see any 0 by 07. I don't see any 0 by 07. So if you take a look here, I want to put a 0 by 07 according to the datasheet. is for reading object temperature. So if you put into here, it should go through here register and should go through here the right, and take a look at the right. I still doing stuff here fixing. Hey, take a look here. So I put the data into the writing register, but nothing is out there. Nothing is out there. Just feel like I'm missing some of the step, which is I try to figure it out. It's maybe soon after this video. So yeah, I figured out, and I think a 20-minute video. I just want to tell you that I made this because my dad, I talking with him about COVID-19, and he worked at health department, and for this time, mass thermal camera, the thermal gun that you see in AliExpress, Amazon, or anywhere, wish.com, is almost out of stock. And I remember that right now in these days, every time I go to RS component website for searching up for some of the components that I will buy in future, they have a red text on the main page telling that these are in what's it called, in they're needed very much. People don't need to spend their money on this stuff a lot because they really need them. So I want to make one for my dad, and this one is about 70% finished to the end, because if I can get around with this working, yeah, everything will work fine. So